Welcome to the deep dive. We've got some really interesting sources today focusing exclusively on the golf swing positions for the lower core golfer.
Yeah.
Yeah, so our mission today is pretty straightforward. We're going to take this biomechanical blueprint from experts Henrik Jentzsch and Henrik Liens and really try to distill it, make it usable. So if your game relies on, using the ground, big hip turn, getting that depth, well, this deep dive should help you understand why that works and maybe how to make it more consistent. We're talking P1 through P9. Okay, let's unpack this.
Right. And I think the first thing to grasp is that this type of golfer, the lower court player, they're really built for rotation and speed. It's not a swing that's going to rely much on, say, lifting the club vertically or tons of wrist action. They're mechanics. That lower center of gravity lets them use the ground really well, generates a powerful rotary motion, and this naturally helps create something really key, a shallower club path. Very athletic.
Okay, so that foundation starts right at P1, the address. The sources describe it as deeply grounded and athletically stacked. Sounds specific. So is it right that the pressure isn't maybe centered like some teach, but it's deliberately focused back into the heels and arches? What's the functional point of that?
Oh, absolutely critical. That heel and arch focus, it's setting things up, it's storing energy. By getting that deeper hinge from the hips, the spine tilting forward quite a bit, you're engaging the glutes, the hamstrings, much earlier, right from the start. It connects you to the ground immediately, stores that rotational potential. If you're trying to feel this, you might feel a little bit behind the ball, chest hovering more over the ball, maybe less over the lead foot.
And that deeper hinge naturally makes the hands sit lower too, closer to the thighs.
Exactly.
So that feeling, that strong base in the arches, it's not just passive, is it? It's kind of the trigger for the takeaway. How does that stored energy kick off P2, the start of the backswing?
Well, that pressure prevents the first move from being, just lifting the club up or pushing it outside. For the lower core player, P2 starts with rotation, pelvis, lower spine. It moves from the ground up, so the club stays low, tracks inside pretty much right away. Hands, arms, they stay working close to the body. It's about rotation creating width, not the arms reaching out. Wrists are quiet.
Interesting. You often hear warnings against taking it inside that early, but for this profile, you're saying it's basically required.
Yeah, it really is. That tight, low, inside move at P2, that establishes the rotational core.
Right.
If the club goes out or up too soon, you lose the depth that we're trying to build later on. You see the chest starting to rotate, but, and this is key, it stays over that trail thigh. That helps maintain the spine angle as you coil up.
Gotcha. So that sets up this next phase nicely. Building depth. Let's move to P3, lead arm parallel. This is where that flatter swing plane really shows up, isn't it?
Unmistakably. At P3, you can really see that flatter, more rotary character. The lead arm moves more around the body, less up, and the club shaft itself, noticeably flatter, often below the shoulder line at this point. Because the hands went deep and inside early, the club now almost forces the wrist hinge. It happens more naturally. It's mainly a vertical hinge, too, which is a direct result of that deep hand path. So the golfer isn't really manipulating the face much. They're just letting the depth create the lag and angle.
So the feel here is loading pressure, trail heel, trail glute, while the arms stay kind of passive and deep, building with horizontally, not vertically.
Precisely.
And that width, that depth, allows for that really significant hip rotation we see at P4, the top of the backswing.
P4, yeah, that's the signature look, you could say. Hands are flat, deep, definitely behind the trail shoulder. Lead arms across the chest, but on a lower path. But here's the really crucial part. To make room for the club to get that deep, the hips have to rotate quite a bit. The sources mentioned 45 degrees, maybe even more.
Okay, wait. Because normally you hear 45 degrees of hip turn, and instructors might flag that, like over-rotation, maybe losing coil. How do Jentzsch and Liens frame that? Why is it good here?
It's what they call functional rotation. For this type of player, relying on ground forces, that big hip turn is necessary. It prevents the club getting stuck and steep. Think about it. If the hips don't turn enough, where can the arms go? They have to lift, go across the line. Forces a steep downswing. So that 45+ degree hip turn, it creates the space, the runway for that deep arm path, lets you maximize the coil while keeping the chest stable over the trail leg. Ready to transition.
Right. Creates the room. So, okay, we're coiled at the top, connected, setting up that explosive ground-up transition. Section 3, starting with P5. Downswing's not initiated by the arms, but the lower body driving.
Yes. This is where you see that separation, the kinematic sequence that powers an athletic swing. The downswing kicks off with an explosive drive. Trail hip, trail leg. The ground drive. And the critical dynamic is that separation. Pelvis starts unwinding, rotating open towards the target, while the upper body, the chest and shoulders, they kind of maintain that coil for just a moment longer.
That momentary lag, that's the secret sauce for speed, isn't it? But it feels like the hardest thing to time, right? What's the actual feel of that separation supposed to be like?
Well, the experts sometimes call it the squat and fire. You should feel this intense pressure building almost immediately into the lead glute and lead heel as the pelvis opens. It's almost like you're dropping slightly into a shallow squat position. That pressure point, that's what generates the ground reaction force. And because of that lag, the club just naturally drops onto that shallower path. Weight shifts dynamically to the lead side, sets up for huge acceleration. That timing difference, the lower body goes, upper body weights, it's just pure stored energy ready to become club head speed.
Okay. And we follow that shallow, fast path into P6, club parallel on the downswing. The geometry here really shows that rotational leverage.
Beautifully. At P6, the shaft is way flatter, much lower than you'd see in other swing types. And look closely. Hands are still deep, still close to the body. Trail elbow is slotted, kind of tucked behind the rib cage. Now notice the separation is still there. Hips are already well open to the target, but the chest is still relatively closed, still holding back.
That open lower body, closed upper body, that's the stretch or separation that transfers the leverage, right?
That is the optimal leverage position. That powerful rotary coil plus the shallow angle the club's on. That's exactly how these lower core players get so efficient. It sets them up perfectly for a consistent inside-out path. They basically maximize their speed potential before the club even gets near the ball.
Okay, stage is set. Culmination time. P7, impact. Where those ground forces peak. This needs a closer look because impact isn't just contact, it's about applying maximum force, right?
Right. And we need to define maximum ground force utilization at P7. It's not just, pushing off vaguely. It's coordinated. You've got vertical force. The trail foot is actively, aggressively driving off the ground. That push helps with launch. And at the same time, horizontally, the hips are fully open past the ball. But the critical piece is that lead leg.
Tell us more about that, the lead leg bracing.
Yeah, the lead leg acts like a post, a brake. It braces hard to stop the rotation almost instantly. If that lead side just kept spinning open, all that rotational energy would just bleed out into the follow-through too early. You'd lose power. That sudden halt, that braking action, is what redirects all that stored kinetic energy, channels it through the club, slams it into the ball. The sources are pretty clear.
Yeah.
The drive creates the power, but the stop transfers it.
Wow. And that braking action leads to the perfect impact geometry for compression. Spine tilted slightly towards the target, chest a bit behind the ball, hands ahead. That creates the shaft lean, puts the low point after the ball. Compression. That powerful penetrating flight they talk about.
Exactly. Yeah. Following that explosion at impact, the momentum carries through P8, post-impact extension, and into P9, the finish. P8 just reflects that aggressive rotation and the shallow path. Hands and arms extend around the body, not hide up. Club exits low and left, tracing that rotary arc. Chest rotates hard toward the target.
And P9 is just the balanced result of all that powerful rotation.
That's it. Fully rotated, totally balanced. Chest, belt buckle facing the target. Shows all the energy was used. Spine is long, trail foot up on its toe. P8 and P9 together just demonstrate the efficiency of the whole system, using ground forces, rotation, driving the swing to a complete stop. Nothing wasted.
Okay, so let's wrap this up. If you're listening and you think you might be a lower core golfer or want to explore this, the key takeaways seem to be get that deep athletic setup at P1, really embrace that big hip turn at P4, and then nail that separation in the squat and fire in the transition at P5.
That sums up the system pretty well. The big message from Jentsch and Lienz is really that if you use this biomechanical profile correctly, it naturally leads to a powerful swing.
Yeah.
Shallower path, lots of speed from rotation. It's a blueprint for power and consistency.
It definitely sounds like a truly athletic golf swing. But let's go back for a second to P7, impact. We spent time on how that lead leg braces hard to stop rotation. Now, when we watch golf, we talk so much about speed, acceleration, how fast things are moving. But here's a final thought to maybe chew on next time you play or practice. Is the real measure of power transfer at impact less about the speed you created and more about the strength and efficiency of that instantaneous stop, that braking action? Could the power of stopping actually be the key to transferring all that energy? Something to think about.